Hello everyone, in this video we are going to take our model from Python and Keras and port it to the browser so that I can draw on the browser and get my prediction using Tensorflow Js. So let's get started. So I am back at our convolutional neural network. So as you can see, it was conv2D 32 with a kernel size of 3x3, a max pooling layer, then 64, a filter of 64, then 3x3, and then a max pooling of 2D, and then you flatten, then 256, then of 10, activation of softmax. So this was our layer, this was the architecture of our model, and we've trained it and we've seen that we get a 99% accuracy on data that they've never seen. So this is very awesome. Now all we need to do is just save this model. So after that it finished fitting, what I want to do is that I just want to say model.save, and now let's say we will call it model.hdf5. So let's see what it does. Let's rerun our code, and now we've added a save statement at the end. So again, I should really delete this stuff. We don't need to show it anymore. And so we're going to train it, and hopefully we'll see that we also get a validation accuracy of 99 or perhaps even higher. So it's continuing, training, and training. And this line is just going to save the model to an HDF5 file, and this is the extension that's normally used to store Keras models. So you get 99, already 99 validation accuracy, which is pretty nice. And now it goes down to 98.93, which isn't bad at all. And we'll continue and wait. So up till the 5th epoch. Alright, so now we've seen that our code finished with an accuracy of 99.18. So let's reload, and now you see that I have a model.hdf5 file. Now I'm just going to create a file called loader.py, and in this we're just going to, from keras.models, import load model. Now I can say model is equal to load model, and then model.hdf5. All I'm going to do is just say model.summary. So Python loader.py. Okay, so saved model does not exist at model.model.hdf5. So let's rerun it. I wrote model.model. Oops. So now it should work. Model.hdf5. And now you see that we get the architecture. That was what we want. conv2D, max pooling, conv2D, max pooling, and a flatten, and dense, and dense. So this is what we want. Now I'm going to use something called Tensorflow Js wizard. And to do so, what I need to do is that we search the web. So Tensorflow Js wizard. And if I remember correctly, what the command that we needed to do is just pip install Tensorflow Js, and we put square brackets, then wizard. So for me, it's not going to work because I'm using a special shell called ZSH, and then when it sees square brackets, it doesn't interpret it correctly. So I can just write bash, which is the shell that the default shell that everybody has on Linux or Mac. And now we can just say pip install Tensorflow Js square bracket wizard, and this is just going to install the wizard with us as well. So it's just like a fancy command line application. You can select which format you want. So pip install Tensorflow Js wizard, and now we have it. So Tensorflow Js wizard, and now when you run it, you'll see that it worked. Now we just have to provide the path of the model file or the directory. So it's model.hdf5. What is your input model format? Keras. Yep, it is Keras. What is your output format? Tensorflow.js graph model. No problem. Do you want to compress the model? Let's say we don't need any compression for now. Okay. What directory do I want to do it? Let's just call it model.js. And so now it's going to convert our model, and now it finished converting, so that was pretty fast, and I don't need the web to do that. Now if you look at my files, I have a folder called model.js. So just exit, and now I'm back at bash, my home environment, and now it's time to do some JavaScript. What I'm going to do is that I'm going to create a file, more precisely a directory, front end, let's say web, and I'm going to go to web. And now I'm just going to try out an editor that I also use, but I prefer to use it for web development, and it is a Visual Studio Code. So code dot, and I think that should be more easy for you to understand also when you use VS Code. And now let's say all I need to do is create an index.html. Now I just put this little template, augment the font size, and now we're right here. So this is what we want, and now I can just say hello world. Let's run it, and now we'll have open with live server, which is an extension that you can install called live server right here, and it will just make a server that will automatically reload your pages when it changes. So open with live server. So now it's going to open it, and as we can see, after it finished loading, we shall get a hello world. So this is what we want. Now I need to make a canvas, and for this I'm going to use a library called P5 because it's just much more beautiful than the default canvas API. So I just need to go to search for cdn.js P5, and this is just going to give me a URL where it will let me download P5. So search for P5 right here, and then you want copy script tag. So from cdn.js, and you copy the P5 tag, and now you paste it. So this is all we need. Now we have this, and so this is nice. Then I can just include some JavaScript by saying script source index.js. Let's call it index.js, and let's say alert, hey, this is JavaScript. I'll just retake back my web browser right here, and now we see, hey, this is JavaScript, so it loaded the file that we wanted. I will just put it right here, just make it like this, perfect. And now let's say that we want to do something more cool, so we're going to do function setup and function draw, and these are functions that P5 will look for, and then it will invoke it respectively. So the setup function is a function that you put the code that you want to run before anything loads. So after the page is loaded, but before you want to draw anything. So what we can do is that we want to create a canvas, and let's say that I make a 400 by 400 pixel canvas. Then here I can just say background of 0, so black. Now if I just disable everything, my uBlock origins blocking, I see that I can load the script tag, and now I have a black canvas. Now I have to make sure that when I draw something, it's going to appear. So we can just say align, not this, align, autocomplete. Come on, autocomplete. Nope. Line, voila, P mouse, past mouse X. So what is past mouse X? It's supposed to be something that will show me the mouse position. So I have mouse X, mouse Y, which are the mouse position, and I should also have P mouse X and P mouse Y, which were the previous mouse positions. So P mouse X from P mouse Y, and now I have to put mouse X and mouse Y. Let's give it a stroke. Oh my god, stroke. Stroke. I want a stroke. Stroke of what? Stroke, a white stroke, so 255. Now let's see if this works as we want. So yeah, it works. It's just that it keeps erasing it. So as you can see, it's working very well. All I need to do right now is just say only when the mouse is pressed. So function mouse pressed, and this is just a function that P5 will call when the mouse is pressed. We don't call it anywhere, it's P5 that's secretly going to call it. So press the mouse, and nothing is working. So to see, oh, is it me or do I see some white blobs right here? So yeah, it's actually working. We do see little white blobs. It's kind of really small, so stroke weight of 8. Now, oh, we have our little dots. Now I don't want to use mouse press, but rather mouse drag. And hopefully it should get a smoother experience. And so now, you see, I have something that's a much more smoother experience. That's awesome. So to recap, create a canvas of 400 by 400. You put a black background, you say that the stroke is white, and you have a stroke weight of 8. Now I just say that when the mouse is dragged, which allows me to do something like this, then put a line between P mouse, the past mouse position, the past mouse position of the Y, and then mouse X, and then mouse Y. So it's just going to take the previous mouse position to the current mouse position. And we can just draw our beautiful digits. So I think it should be maybe a bit higher. So stroke weight of 14. Okay, how about 18? What's the thickest stroke we can have? Okay, I think that with a stroke weight of 18, it does look like the MNIST dataset. So MNIST dataset, if you want to look at it, some images, we see that the stroke, it seems pretty alright. The stroke is good. Now we need to import something called Tensorflow Js, which is just the JavaScript version of TensorFlow. So copy script tag from cdn.js, and now I'm just going to say, put it right here. I also need to drag and drop the folder that I had for the TensorFlow, so model.js. So here, right here, I have my model.hdf5, and now if I open it, you'll see that all I need to do is take this file, take model.js, and then drag and drop into web. Now we get model.js inside, and it's pretty good. So model.js is inside, and we have our model.json and everything. If I remember correctly, all we need to do when we want to load it is just say that let model is equal to await tf dot await what? Let's see, reload 9. Alright. So in this case, let's put it full screen. Let's put a console at full screen, increase the font size. TF, we have TF dot load graph model. This is what we want, and now I have model.js slash model.js slash the name of the JSON, so model.json slash model.json. So let model. So what does this give? This gives me a promise. So this is not what we want. What I want is a model. All I need to do is just put an await, and it's just going to get the value inside a promise. And a promise in JavaScript is just something that the function will return to you and say, oh, I'll calculate it later, but right now here's the proof that I will calculate it. And with this object, you can just wait for it and then it will get the result. So I just put await keyword in front of a promise, await tf.load graph model model.js slash model.json. So let's just say let model equal to this. And now we have our model, and technically I should see a predict function. So we can do model.predict. Can we also do model.fit? Oh, we can't fit, but that's okay because we only need to predict. This is pretty fun. So let's just put this code right here. Let model is equal to let model, and then here I'm going to say model is equal to await tf. This is one of the reasons I don't like VS Code. It is so intrusive. Load graph model.js slash model.json. So we've loaded our model, and now we just need to do nothing, and we have an error. So await is only valid in async functions and async generators. This just means that it's not in an async function. How do we correct it? Well, then slap an async in front of it, and now we have no problem. I can have model, and now you see I have the correct model. So this is our model. And right now we'll want to draw. Okay, and now I want to be able to get this stuff here. How do I get this image and resize it to a 28 by 28 image? What I can do is that when I say create canvas, I can just say this is equal to my canvas. And you'll see that it's actually a very useful object. So let model, canvas. And now if I look at canvas, I can have something called canvas.elt. And this gives me the canvas element that I want. With the canvas element, Tensorflow can take it and get the pixels already made for me. So I can say tf.browser dot 2 pixels are from, I think it's from pixels of canvas.elt. And oh, we get something. Let's print it. And look, we get just a lot of zeros. I think this is pretty standard. Let's just put some white. We should get some 255 or some ones somewhere. So let me just put the top left corner white. And now we see you get some 255. So this is very awesome. So this successfully converts our model. But now what I need to do is that I have the tensor here and I want to divide by 255. But before that, I want to resize the image. So dot resize, is it 28 by 28? Does this work? Nope. It's resize by, so let's see the web. So Tensorflow Js resize image. taken from browser. Let's see if this gives us any answer. And it does look like what we want, tf.image.resize. But this is Python, oh come on, not Python. So Tensorflow Js. Oh, resize by linear. Is this what we want? Resize image. So create, nope, 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 nope. Maybe this one. Yep, let's look at this one. And now we have tf.fromPixels, and finally we get this tf.image.resize by linear. So this is what we want. So we have that our let pixels is equal to tf.browser.fromPixels canvas.elt, and that can say tf.image.resize by linear pixels 28 by 28 dot shape. And now I have a shape of 28 by 28 by 3. I only want to get one channel, so I can just say mean. Let's see if this works. Nope, it does not work. So now we'll take another search from the internet. So Tensorflow Js, convert tensor to grayscale. So we have Stack Overflow, our wonderful friend, and this is r.molefactor.add. Yeah, I see this, but I don't really need anything that's that fancy, and I get it. It's this one I want. So tf.browser.fromPixels image.mean2 .toFloat.expandDims -1. So copy paste, full screen this, and let's say .mean of 2 .toFloat.expandDims. Delete this, run it, and now I can just say .shape. Now I have a 28 by 28 by 1, which is what we wanted. Also, if you remember correctly, we have to divide by 255 because we did that before, and the model expects us to give something that looks like what it was trained on. So .div by 255. Let's say if we can print it. And now if we printed 00111, this looks exactly like what we want. So this is pretty awesome. Now, let's see what we can do. We can copy this line here, and let's call it function get image tensor. And in our case, we're just going to say tf constant pixels is equal to what? The pixels are equal to tf.browser.fromPixels canvas.elt. I got these pixels. Now, what do I need to do? I have to use this magical line to resize it, convert to grayscale, convert to float, and divide by 255. So what does this line does in particular is that it takes this image, resizes it to 28 by 28, takes the mean from the second axis, which is just going to output a 28 by 28 numpy array, and then you add a dimension to the last, to the last axis, so 28 by 28 by 1. This is pretty awesome. So we got our input tensor. So constant, let's call this constant image is equal to this. So input is equal to this. And now if I say model.predict, and now because it accepts a batch size, we need to put a array on top. Let's see if this works. I can just test it right here. So what was the line? Yep, this is the line I want. Let's call it let input is equal to this, and as always we can just say input dot model dot predict input. This is, I'm pretty sure this is going to give me an error. Yep, so this is not the same thing. So what about model dot predict input like this? R is not defined. This looks kind of unreassuring, not assuring. tf.tensor. Okay, let's try something else. tf.tensor input. So the shape of dict input 1 must be -1, 28 by 28 by 1, but width of 1. Is that really the case? Input is not defined. Oh, that's because I printed it here. Oh, now I get it. So input is equal to this. X must be of rank 3 or 4 but got rank 1. What are pixels now? Pixels are empty. So let's just reload our page and start from scratch again. Let's put it our beautiful 9. So let pixels is equal to tf.browser.from pixels canvas.alt. We have pixels. We can print it. That's nice. Now we just need to say pixels dot to float pixels dot tf dot image dot resize bilinear the pixels 28 by 28, and now I have to make sure I take the mean axis 2 dot expand dim -1. So how about this? This works. Dot expand dims -1. Yep, now this also works. Now I just need to say dot div by 255. So this is divided by 255, and I can just say that input is equal to this. Since it said that it accepts also, it also wants a batch size, let's just wrap this and add a dimension at the first dimension. So this should give us a shape of 1, 28, 28, 1, which is what we want. So input.shape 1, 28, 28, 1. Now if we feed this to the model, it should not complain. Model.predict input. Okay, it doesn't complain. This is awesome. So let output is equal to this, and I can just say output.print. Maybe. Oh, output.print. And I see I have 0, 0, 0. And remember that the last index was 9, and we have 0.98 for 9. So this is awesome. Very awesome. Wow. Okay, so output, let's just convert this to n. Is there a way to get argmax? Yeah, argmax. What does this gives me? Print. Is this what we want? Nope. Argmax -1, tensor 9. So this is what we want. Argmax -1. So it's going to take the argmax for each underlying array. So output.argmax -1. Now I get 9, and now I have to say to an array sync. Yep, now I have an array, and to get the prediction, I just put this. So this is awesome. We got everything working correctly. So let's say dot expand dims -1 dot div by 255, and we don't forget to expand dims at the first to get a 1 by 28 by 28 by 1. 1 by 28 by 28 by 1, that is scale from 0 to 1, and that is resized to 28 by 28. Now we have let output is equal to model.predict that input, and I can just say right now, I can say output dot argmax -1 dot array sync then 0. So I can say let prediction is equal to that, and now I can just say, let's say text P5, not you VS Code, the web, HTML, whatever, text, let constant, I should use constant if it doesn't change, constant, so constant prediction text is equal to my f strings, but in JavaScript, so backticks, prediction of prediction. So text, prediction text. Is there a way to just say show prediction, show text, prediction, text? Alright. So function show text, we didn't define this function, so function show text, message, and we're just going to add a string that's dedicated for our message. So div dot prediction text. So div class of prediction text, and here I'm just going to say document dot query selector div dot prediction text. So what does this gives us? Document dot query selector div dot prediction text, and we get this div that's non-existent, but it still exists. So let element is equal to that, and we can say element dot text content is equal to hello, and we have it here. So this is awesome. So constant element is equal to this, and now I can just say element dot text content is equal to message. Alright, let's rename this function to function predict. So it's just going to keep predicting over and over. Now, all I need to do is just, after you predicted, well, run the predict function again, but after, like, let's say 500 milliseconds. We just need right now to say in function setup right here, as soon as you start dragging the mouse, let's say we actually don't need to say a set timeout, we just say that after you drag the mouse, we predict. So if this works first try, I'm going to be very happy. Prediction of 7, alright. 7. Oh, that's not what I want. Oh, prediction of 7, yeah, nice. 9. Do I really write that bad? 1, yep. 2, alright, not bad, not bad. 3, oh, beautiful. 4, yeah. 5, okay, alright. 6, 6, no, 6. Oh, no, it's not a 5, 6, 6, 7, 7, yeah, 7, that was definitely a 7, 8, 8, and then, is it a 9, is it a 9? Nope, that's not a 4, 9, come on, we just need this last digit. Was it even predicting? 9. Hey, 9, it works. Alright, so this is our model. It works correctly, but sometimes because the MNIST dataset is all standardized, it's kind of hard to make it work perfectly on the web. But as you can see, 1, super easy to detect. 2, pretty easy to detect. 3, also easy to detect. 4, easy to detect. 5, easy to detect. 6, easy to detect. 7, easy to detect. 8, easy to detect. I think it's only the 9 that's the hardest. Yeah, 9 is the hardest one to detect. Oh, but we get errors. Model is undefined. Oh, that's just because I've started drawing before. So, no, yeah. 9 is too difficult because it looks like a 1. So what if we do something like this? 9. I'm really having a lot of fun with this model. I think everybody should just start counting from 1 to 8. I think 9 is a useless number. If our model doesn't pick it up, it's a useless number. Alright. So, that was super easy. That was pretty much all we needed to do to predict our model. We can even deploy it to Surge. We can even deploy it online. And all we need to do is just open up a terminal. And then, if you have npm installed, you can run npm install -g surge. And this is going to install Surge for you, which is just a super useful command to just deploy websites. And now, if I just add a CNAME file here, and I want this to be called Pooky codes mnist.surge.sh. So this is just going to read it when I run Surge. So let's do Surge of this. Yep, okay. And now it's going to publish. So wow, that was pretty fast. So I can technically now go to just this link right here, open, and make sure that I don't block anything. And we have our canvas. And now if we just draw a 9, we have a prediction of 9. So as you can see, when it's deployed online, 9 also works. So this is awesome. 1. Okay, this is nice. 2. This is awesome. 3. Oh, it's awesome. So finally, in this video, we've seen how we can port our model from Python and finally create something that can detect the digits in the browser. So that was all. Thanks for watching. If you like this content, like, subscribe, do all that good stuff. And in the next video, we're going to look at an alternative approach to serving your Python models by using a backend called Flask.